Okay, lesson 7.8. Now we are going to be factoring the trinomial um, where a is not equal to 1. So in lesson 7.7, a was equal to 1, and it was pretty easy. So now we're going to have like a coefficient greater than 1 for a. So 2x squared plus whatever, or 3x squared or greater. So we want to first look and see if there is a greatest common factor or GCF or something of the terms of the polynomial that we can factor out first before we begin working with our factoring. All right, so we're going to take a look at that and let's work through some examples and see what happens. All right, so these first three, looking for the greatest common factor. We're getting very, very close into being able to factor completely. So greatest common factor. This is a even. They all have a factor of 2. So if I factor out a factor of 2, I'm left with c squared minus 7c and then minus 18. Now, this part right here is very much like last lesson where we had a leading coefficient of 1. So we're looking for factors of negative 18 that sum to a negative 7. So we're looking for factors of a negative 18 that sum to a negative 7. And you can probably do those in your head, like, 2 and 9. And then one of them is negative. Since this is negative, the higher absolute value has to be negative. So don't forget your factor of 2 that you factored out. You'll have c plus 2 times c minus 9. Okay, and again, double check that when you multiply it, that you get the trinomial. Okay, moving on to number 2. Again, looking for anything to factor out. Now they're all even, so we could factor out a 2. But if we factor out a 2, it looks like we're probably left with another even. So I'm going to try 4. Factor out of 4, we would get a squared plus 2a, and then 140 divided by 4 is 35. So all we've done to start with is factor out of 4. Okay, now we're left with this trinomial, leading coefficient of 1. We're looking for factors of negative 35, okay, that will sum to a positive 2. So we're looking for factors that will sum to, so I'm thinking 7, 5, right? 7 and 5 are factors, and the difference is 2. It's a positive 2. This is negative, so this must mean it has one negative factor. So we should have 4 times a plus 7. And again, the order you write these is not as important. And again, try to work it forward, to multiply it, to see that you get this trinomial. Okay, looking at number 3. We look for a common factor, and I can see that the common factor here is 3. So I'm going to factor out a 3, and I'm left with x squared minus 2x and then minus 8. So looking for factors of negative 8 that sum to negative 2. Okay, so factors of negative 8, we have, 2 and 4 have a difference of 2. This would make the negative 4. So we'll have 3 times x plus 2 and x minus 4. Again, double check that when you multiply all these together, what you would do to check that is go ahead and FOIL these and then multiply everything by 3, and you should get your original trinomial. Okay, now we're going to start looking at some of these, starting with number 7, right? 12, 37, 28, no common factor. I'm going to actually skip this one because I want to show you what's called the rainbow method. So we're actually going to work in reverse. Let's work in reverse here. So the rainbow method, we need to find out, we have to figure this out. We can't, we don't have a leading coefficient of 1. So in our little diamond pattern, if I had it on the little pen tab, in our little diamond pattern, if we draw a rainbow right here, yay, and we multiply these outer terms together. So we have to multiply the outer terms together. So 9 times 2 is 18. Okay, so we have that, and now we need the factors of 18 that will sum to 9. Okay, it's positive 9. So factors of 18 sum to 9, 6 and 3, pretty easy. Now what we're going to do is we're going to transform this middle term, okay? So we're going to rewrite the trinomial, so 9w squared. And now instead of the 9w, right, which is the sum of 6w plus 3w, I'm going to rewrite it as plus 6w plus 3w. And then we have this 2. Okay, so look what we did. We took our 9, and, which is the sum of these two numbers right here, and we broke them back up. Now, I'm going to just divide this in half. I'm only going to work with half of this polynomial at a time. So when I look at these two, and I want to pull out the common factor, we did this, in lesson 7.4 possibly. So we're just looking at these two for a greatest common factor between 9w squared and 6w. I know it's going to be 3w. Okay, so 9 divided by 3 is 3. W squared divided by w is w. 6 divided by 3 is 2. And, the w comes out. All right, so we have hold on one second. Okay, now I'm looking at these two right here, and look what we have, 3w plus 2. So I'm just going to, let's just say I factor out a positive 1. So I'm going to factor out a positive 1, and I'm left with 3w plus 2. So hopefully at this point you're seeing that this factor right here and this factor right here are the same. They're the exact same factor. So that's going to be one of our factors. We will have 3w plus 2, right? It's one of our factors, 3w plus 2. Our other factor is going to come from, let's do a pretty green color. Right here, we have this 3w and this plus 1. And if you can recall from lesson 7.2, when we started first, we did like a double distributive. We took the first term times the second binomial, and then we took the second term times the same binomial. We could rewrite these as 3w plus 1. So think about like when you had two binomials that you were multiplying, you took 3w times 3w plus 2, and then 1 times 3w plus 2. All right. So this becomes our factored polynomial right here. And you can tell and check your work to see if it's correct by, first, outer, inner, last, foiling, whatever. And you need to get back to this original trinomial up here. So I know it's a lot of steps, so we're going to do this step by step. Okay, looking at number 8, we have the rainbow. Okay, so please let me know how to set this up. How would I start this problem? So please answer the question of what is it that I need factors of? What is the product of these two numbers that I need factors of? And then what does the sum need to be? So what is the product? What are the factors? No, I don't like that idea. Okay, for number 8, we want to make this little diamond here, all right? Remember that we want to multiply 6 times 4, so this is going to be a positive 24. The sum is going to be negative 11. So we need factors of 24 that sum to a negative 11. So go ahead and pause the video and let me know what two factors you come up with, and make sure that you have them as integers. You don't need the binomials. You don't need to factor it all the way completely. I'm just asking for what two factors of 24 sum to negative 11. All right. Well, hopefully you came up with the fact that 8 and 3 have a sum of 11, and to be a negative 11 and a positive 4, they must both be negative. So negative 8 and negative 3 were the correct answers we were looking for. Okay, so what we've just done now, remember we did our rainbow. Now we're looking to break this negative 11k up into the sum negative 8k and negative 3k. So we're going to rewrite the polynomial. 6k squared minus, and it doesn't matter which order you put these sums in, okay? So look at how this resembles the original, right? All we've done is broken up this middle term into the sum based on this. We multiplied a times c, right, to get this number 24. Okay, this is just a way to organize your work. You can also see the examples in the textbook where there's tables that are very, very long. And so I personally really like how this is a shortcut in a way that we're trying to teach you. All right, so now we're going to, draw the line between the terms. So I left the negative with the 3. Now I'm just going to work with these two. I'm going to look for a common factor. K is a factor, it looks like 2. So I can factor out at 2k. And so 6 divided by 2 is 3. K squared divided by k, and then 8 divided by 2 is 4, and k divided by k. So 3k minus 4. Here, do you see negative 3k plus 4? If I factor out a negative 1, I will get a positive 3k and a negative 4. So this is where you have that power to kind of change it to know you want what's inside the parentheses on the right-hand side to match what's inside the parentheses on the left-hand side. So if you make a mistake, double check it, things like that. If it's not working out, see where the mistake is. All right, so now our common factor is the 3k minus 4. We know that that's going to be one of our factors, 3k minus 4. Our other factor comes from what we factored out, 2k and minus 1. And again, you can try these out. So 2k minus 1 and 3k minus 4 does not matter which order these are in. All right. Now, the reason we saved number 7 for last, because if you can see kind of what's going on here, when we do the rainbow, okay, 12 times 28, I got 336. So when I start looking at this, right, 336, it's a big number. And then it has to sum to a negative 37. So we have a lot of factors of 336. In fact, we need to, one way that you can do this, I don't know if you call this from divisibility rules, but when you're doing factors of this and you want to know, like, how do I know when I'm done testing numbers? Because we're not going to be able, this isn't in our multiplication memory bank. We have to just actually try them out on a calculator. So you're gonna basically want to make a list of all the factors. When you know you're done testing numbers for factors is if you take the square root of 336, all right? So on my calculator, I'm going to take the square root of 336, hit the square root, I get like 18 point something. I need to test divisibility. My goodness, divisi. Divisibility to 18. So that's a lot of numbers, right? So you might still need to make a table because but then again, some of these numbers aren't going to make sense because 1 times 336, remember that we need the difference or sum to be, 37 as an absolute value, and then we'll deal with the integer part of it in the negatives. But we could go through the list, right? You could take 336 and divide by 2 and you get 168. Is it divisible by 3? Well, 6 and 3 and 6 plus 3 plus 3 is 12, and 12 is divisible by 3, therefore it is divisible by 3. So take 336, divide by 3, and get 112. If it's divisible by 4, the last two numbers will be divisible by 4, so it should be divisible by 4 as well, and that's 84. Again, the difference here is 80. We're still not close. So then if it's divisible by 2 and 3, it's also divisible by 6. It's not divisible by 5 because it does not end in a 5 or 0. So these are all, so let's see, divided by 6 is going to be 56. Then you just have to try 7. Is 336 divided by 7? Try it out. Actually, it is. All right. Is it divisible by 8? Yes, it's divisible by 8. 8 times 42. Again, the difference here is not 37. So, or the sum, these do not sum, sorry, I don't know, why am I saying difference? I don't even know. But the sum is not 37. So we still have a long way to go. Let's see. It's not divisible by 9 because 12, when we add them together, is not divisible by 9. 10, it doesn't end in 0. Try 11, it doesn't work, but it is divisible by 12. So 336 divided by 12 is 28. And these do not sum to 37, but looks like we're getting close. Try 13, try 14. 14 times 24, and that looks like we're getting close. And then not divisible by 15, but it is divisible by 16. And we have a winner, okay? Because 16 and 21 equal 34, and because it's equal 37, and it's a negative 37, we want both of these to be negative, right? So that's how we deal with the integers. It's a positive, this is positive, and this is negative, so we want it to both be negative. So now we're breaking up negative 37, so we're going to have 12g squared, and again, it doesn't matter which one comes first, 16g minus 21g plus 28. So remember, we go back to the original c for this part of the factoring. And then we divide this into two parts. And now we're looking for a common factor, the GCF of 12g squared minus and 16g. And I find that to be 4g. So I'm going to divide out of 4g. So 12 divided by 4 is 3g. And then this divided by 4g is minus 4. Okay. Here, reading negative, so I'm probably going to divide out a negative, especially since I need this to be minus 4. So let's divide out a negative 7, and we'll be left with 3g minus 4, and that's how we know we did it right, because we have the same common factor. So that's one of our factors, 3g minus 4. And then our other factor comes from this 4g and this negative 7. So 4g minus 7. Again, try it out. Make sure that the product here is the 12g squared minus 37g plus 28. So do FOIL to check your work. All right, moving right along. In this next section, remember the first step is to look for a GCF. And since the leading coefficient is negative, we want to factor out a negative 1. So let's factor out a negative 1 here. So if I factor out a negative 1, I'm going to be left with a positive 2d squared plus d minus 6. Now this is where I get to do the rainbow method, right? We've got to keep this negative factor, negative 1 factor, but we can do the rainbow method right here. So the top number that I need the product of is going to be a negative 12. I need factors of negative 12 that will sum to a positive 1. And that looks like 3 and 4, right? So 3 and 4. Since this is negative, one of them is negative. Since this is positive, the highest absolute value is positive, so that must make this negative. Now, these numbers are splitting up this positive 1. So we will rewrite this. I'll keep the negative 1, and we'll have 2d squared minus 3d plus 4d minus 6. Okay? Now this is where we divide it in 2, and we're going to work with just this half. So the only thing we have in common here is the d. So we will leave behind 2d minus 3. Here we have a factor of 2. So we're factoring out a positive 2. And we're left with 2d minus 3. So our factors become, don't forget about this one, factored form would be negative 1 times the first two terms, the d plus 2, and what's in here, the common factor of 2d minus 3. And again, you can multiply this all together, and the way you would do that would be you could FOIL this to get the trinomial and then times it by negative 1. Okay, I know this was a lot. I want you to go ahead and try number 17. I want you to try 17, work it out, pause the video, work it out, and then we'll move on to 18 here in just a little bit. All right, I'm just going to give you the final answer for number 17. Now that you've worked it out, you can check your work. You should have gotten negative 1 times, and the order of the factors will not matter. R plus 1 and 3R plus 1. So this was number 17. Okay. Then you would have factored out the negative 1 to begin with. All right, so for number 18, factor out the negative 1 because the leading coefficient has a negative. Then we're left with 8x squared minus 14x and positive 5. So factoring out a negative changes the signs of both of the other terms. Now for the rainbow. 8 times 5 gives us a top number. We want to find factors of 40 that will sum to negative 14. Factors of 40 that will sum to negative 14. Well, looks like 10 and 4 would. So if I put 10 and 4, now because this is positive, they're both negative, and when you add them together, you get negative 14. So what we're doing is breaking up this negative 14 into negative 10x and negative 4x. So we're going to keep this negative 1. 8x squared minus 10x minus 4x and plus 5 from the original polynomial right here. These are the two that we're going to, two halves or two sides we're going to work with. We're first going to factor out, looks like we can factor out a 2x over here. So that's 4x and minus 5. And since this is negative 4x plus 5, and we need it to be 4x minus 5, we can factor out a negative 1. So we'll get a positive 4x and a negative 5. So we can get our common factor. So we have negative 1. We have 2x minus 1 and 4x minus 5. Again, try it out by using FOIL or double distributive or whatever. When you start to set up your double distributive, it should look like this, and that's one way that you know that you are doing it correctly. But you do want to check your math just to make sure you didn't make any mistakes. Okay, lesson 7.8 vocab and concept check. Go ahead and identify which one you will be responding to. Please use complete sentences. And then if you have any questions, be sure to let me know. And then I will be doing my best to help you in class tomorrow. And have a great night. And I will see you tomorrow in class.